What is equality? We can look at it as a relation that obeys some axioms. Since equality should behave like an equivalence relation, it should be reflexive, symmetric, and transitive. It turns out that these are not enough to describe equality completely. Let's say that we have a property that x is prime. Let's assume that 2 is prime and 2 is equal to the successor of 0. Then by making a substitution, we should be able to conclude that the successor of 0 is also prime. But we do not have an axiom that allows us to make substitutions like this. So we must add a new one. The axiom should look something like this. If x is equal to y, then saying that x has a property p is the same as saying that y also has that property. More formally, for each property p of x, we add the following axiom. We can write it in a more general form for a property of n variables. We are not done yet. Consider the operation of addition. Let's say that 1 plus 2 is equal to 3, 1 is equal to the successor of 0, 2 is equal to the successor of 0. Then by making a substitution, we should be able to conclude that successor of 0 plus the successor of 0 is equal to 3. But we do not have an axiom that allows us to use substitution in the case of operations. We only have that for the case of properties. So we will have to create one. It should look something like this. If x is equal to y, then applying an operation f on x should give the same result as applying it on y. More formally, for each operation f, we add the following axiom. We can write this in a more general form for an operation of n variables. Now we are done. These are all the axioms of equality.